So yeah, let's just jump right in. Welcome to another edition of Modsy Tech Talk. We're going to be doing these hopefully every Friday afternoon if you're on the East Coast. And these are just kind of hopefully a casual chat session to just talk about MLOps space, what we're seeing, what our partners and customers are doing, and it's an opportunity to talk with everybody here, learning what y'all are up to and what you're working on. As we go forward, they might be more and more interactive. I know we're just on the third one now, or technically the second one, depending on if we're counting from zero. But if you have an idea for anything you'd like to talk about, drop it into Tech Talk Ideas channel. We're going to be, kind of dynamically making the schedule as stuff goes forward. But that said, next week we're going to be talking about explainability, which is going to be a really fascinating topic. We have a couple of different patents, and Clayton will be talking about all the ins and outs and intricacies and a lot of the industries that require explainability around their ML models. It's going to be a really fun one, and then the following week is one that I'm personally looking forward to, is our kind of a hardware focus, where Nathan, I believe, will be chatting about CPUs, GPUs, FPGAs, all the considerations around ML and AI when you aren't running on, just a standard AWS instance, and how to optimize and fix a few issues around those sort of things. But moving forward, this week, we're essentially just going to talk about AI everywhere. Hopefully this is going to be a pretty light, casual topic, but we want to talk about how AI can actually be used in the real world and how to integrate it into applications and tool chains for the end users. To go back a little bit, last week, Seth gave a great overview on model ops, the whole tool chain. You can review that in the Tech Talk archive channel, and I think we've got it on YouTube as well. But essentially, Seth talked about bridging that chasm between ops and training. And he mentioned, but we never got into that third leg and potentially that third hurdle of actually running your AI models in production, and how to get them into the hands of end users. What can we do and what do we actually do with ML? So today we're just going to talk a little bit more about real-world examples of how AI can be used to answer actual questions and be integrated into existing tool chains, that sort of thing. Again, kind of grepping from last time, we got this nice architecture diagram, and everyone here, all the data scientists live and breathe in these left 4 columns. We do the data, we do the engineering, we do the training, and potentially we work a little bit in the ops column. But this 5th column, which we didn't even touch on yet, is really, at least in my opinion, ultimately the whole reason for everything that we do. Management doesn't give us those amazing DGX boxes or buy the 10 GPU chassis that let us train at high speeds or pay for those amazing and interesting data sets, unless ultimately it can generate what the MBAs might call value, what we might just call results. But if we can't use the outputs of those models, nobody's going to give us the money or the time to work on them. So there are a lot of factors that make AI really difficult. Obviously, Seth talked about a whole bunch of just the factors that make training difficult, that make implementing difficult, that make bringing into the operations and the production cycle difficult. But for the end user, there's just a bunch more difficulties. Obviously deployment we talked about a little bit last time, letting someone else run your model. Discovery is a huge issue. How do I know what models are, what models exist, how they work, what kind of data they work with? Scaling models, can I run it? Can 100 people run it? Can 1,000 people run it? Or can it be run on terabytes of data versus just being run on my own computer? A lot of those are definitely hurdles. but today we're just going to kind of jump a little more deeply into this fourth one, and that's integration. Integration is essentially putting the algorithms you're designing and training into real-world use. Putting them into the hands of analysts, users, managers, that sort of thing, in the tool chains that they're used to, in order to get answers to the questions that they want. Quick picture of end users. This is a very, very broad spectrum that we have to consider. Everyone from actual data scientists, other people like yourselves, who we are. We're making these models, and sometimes we're making them for each other. It could also be very sophisticated analysts who have jobs, that is, looking at this data, coming up with answers, all the way to consumers who may be very savvy, all the way up to just our friends and family. If you've ever used like the Paprika recipe app, that's using ML and AI to parse recipes so that we can make food at the end of the day. But those particular users don't have any understanding that they're even using an AI ML algorithm. So for most of the end users, this is kind of our goal, is to just make it invisible, make it integrated into their everyday life, and make it usable without them having to learn, YOLO v3 implementations and TensorFlow. So just kind of recap what integration is solving a problem, hopefully with existing tools, and making it usable by the people who need to use it. In many cases, I think AI is the product. Technologies like Siri, like Google Search, the product is an embodiment of the AI that's backing it. That is the full thing, but at least from my perspective and my day-to-day job, in most cases that algorithm that you're working on is a very small portion of the overall solution. A lot of times what we want to do is identify a problem and then just figure out a faster, more efficient means to an end. Reduce, accelerate, eliminate repetitive, monotonous tasks. All these things are prime candidates for ML and AI algorithms. We just have to identify that problem and then identify a solution to it through a model. But once you've accomplished that, you do need to integrate with existing tools. We all love to use the latest trend in UX design, the best cross-platform frameworks to make our own web app or iOS app. But in my experience, the aerospace industry that needs that algorithm is running on Fortran. The hospital that needs to identify, is this scan cancerous or benign, they're running everything on Epic or Athena or some older tool like that. Or, what I see more often than not now, everyone is running their entire customer support platform through something like Salesforce. So your unique, amazing ML model that solves every single one of their problems, if it doesn't work within one of those tool chains, whether through regulation, policy, or just training and inertia, it's not going to get adopted. And then finally, the end users, the analysts, are often exceptionally sophisticated and very, very intelligent, but again, they're not going to know or care that you use the TensorFlow implementation and found a data set from Lawrence Livermore National Lab. They don't care about any of that. They just want an answer to that initial problem that we identified, and they want to do it in a way that they're used to. Again, going back to that user chart, whether that is running an iPhone app that simply gives them a recipe, or right-clicking within one of their very sophisticated tools, they need to be able to use their existing knowledge without learning, without installing Jupyter notebooks or something like that. So that's kind of a preamble. Hopefully we can agree that integration really is the key to getting people to actually using ML and AI models, actually making all this work worthwhile. But I guess today we kind of wanted to touch on, as ML AI engineers and data scientists, we often don't get to touch a lot of these tools. Tableau, Salesforce, ArcGIS. You've probably never been inside these, never gotten to see what users are actually how they're interacting with the data, how they're interacting with the models. So just kind of wanted to give a really light overview of some of these tools to just kind of give you all like an introduction to how some of these folks see things. I guess I could pause there. Any questions or feedback or thoughts so far? We do kind of want these to start being interactive as we move forward. All right, sounds good. So I'll just start with one of the more common use cases.
You're doing great, Brett. Love it so far. Just wanted to make sure you weren't. It's not crickets here in the audience.
No, just talking to dead space. Yeah.
No,
sounds
not
good. Yeah. So I'll start with something that I see very, very commonly with ML models in particular, and that's just data mining applications. Satellite imagery is the classic use case. It's huge. It's updated practically on a daily basis, sometimes even more often. And many times the use cases are a bit like finding a needle in a haystack or counting jelly beans in a jar. Very monotonous, very tedious, and exceptionally high volume data problems. Like Seth, you mentioned last time, analyzing the entire state of California for wildfire susceptibility. This is a very common use case. Right here on this slide, we're seeing stuff like building detection, building segmentation. We can detect new neighborhoods, new construction. We can determine square footage of 1,000 houses in a matter of seconds. We could take imagery from very unsophisticated UAVs or aerial platforms and actually align, register, and reproject that to some of the more sophisticated imagery platforms like satellites. Very, very tedious, very time-consuming work if a human were to do it. In fact, you could characterize, again, just rolling down this, we could characterize every single street in an entire city. Tag potholes, tag cracks, tag areas where improvement is needed so that the city managers could triage that and deploy their maintenance crews with a good schedule that hits the highest needs first. And of course the classic use case that you hear more often than almost any others is counting vehicles. It does sound like a very funny use case, but the number of cars in every Home Depot parking lot in the country, how are you going to count that without AI? And yet investors find a data point like that to be exceptionally valuable. Number of large trucks on a freeway could show the health of the transportation, logistics industry. The number of cars in a factory or warehouse parking lot, as day-to-day, the ebb and flow, watching that, you can determine, is that factory or is that warehouse up and running? Has it shut down for COVID? Has it shut down for other reasons? Are there supply chain issues? All this stuff is exceptionally valuable to investors and their ilk, who will, of course, give us all a lot of money to develop them. So how do they actually take advantage of it? What we're seeing here is QGIS, ArcGIS as well. What they often do is get someone like me, I suppose, a solutions engineer, to take your model, wrap it in a very simple wrapper, and then add it as something like a plugin. Now what do? They import their aerial imagery. They know how to open up their processing toolbox, open up that plugin, and then run it against that imagery. Hopefully it's exactly that simple. They can then go further and take this data, process which of these might be a lower score. I mean, we can see some air conditioning vents being identified as vehicles. If we dove into the data, we'd probably see that that's 25% likelihood versus some of these other cars are much higher. But this is how they're going to be exposed to your model. And if we go even a step further, out of something like a GIS application like ArcGIS or QGIS, we jump into something like Tableau. Tableau's sophisticated in a very different way, but again, the end user is going to see something more like importing a list of satellite images, however many hundreds or thousands of images that happens to be, run a script that calls your model, runs all that source data through your model, and generates an output file. They're not going to be running, a Jupyter notebook or something like that. They're going to be running an application like this, like Tableau. So we need to make the data usable for them, structured in a way that they can now use it. We ended up outputting a lat long and a score here, which the analyst can then just drop into his rows and columns of Tableau. But this is they are never going to look at a line of code, is I guess the point here. They want to use GUIs, they want to use graphical user interfaces, they want to use the tools that they're used to and accustomed to process and analyze that data. Tableau does make it very easy. There's extensions called Tabpi or an analytics extension server, and a few other ways that we can bring in the data, run Python scripts, run JavaScripts, not JavaScript, but scripts written in Java. All those, lots of good ways to extend this. But again, probably an ML engineer or a solutions engineer is going to be writing those to bridge that gap between the model and the actual analyst application. Tableau again, this is just a great charting application. We see, Tableau is an example, but we also see this Power BI, Click, a few other charting applications where it simply takes data and creates graphs that the analyst can then use to come up with results, answers to deeper questions. This one is another reviews dashboard. We had a particular client who every single day pulled in the Amazon reviews of their various products and then analyzed those reviews for sentiment. This is different from the number of stars, although it's extendable to customer interactions, customer complaints, that sort of thing. Once we can categorize it as negative or positive, we can start charting that over time. We can say, oh, hey, our product went from version 2 to 3, and the average sentiment, the negative spiked and the positive dropped on the day that we released that. Why? We can start looking into that. We can start releasing version 4 based on that feedback. Again, rolling back based on that ML model that characterized and that we were able to surface a change in the overall customer sentiment toward our product. So it's a very common use case, again, right within Tableau. All this is running automatically in the background on those Amazon reviews. I mentioned before, Tabpi Server, maybe a customer is going to see something like this, where they can see their deployed models, and then they can see how to run them, what data it takes in, what data it takes out, or pushes out, but that's about it. So for folks like us, we're going to want to wrap that model into something that is usable. And this is essentially 100% of the code behind the Tabpi implementation. We create a very simple function to call a model. Not that this is an advertisement for Modsy, but Modsy makes it very easy by exposing all this with pretty consistent RESTful interface that you get a key and a URL and a model ID, and you can call that model. We then take the output of that model and format it in a way that Tableau likes to see. Tableau basically runs everything in a data frame format. And then, this last line, we simply deploy that to the Tabpi server. It's just kind of an example. In general, the customer themselves isn't going to see this. Somebody will have deployed that to Tabpi, and everyone within that organization who's using the Tableau will get access to those same functions. And they just, like we saw a couple slides ago, they just get to drag that output file into their visual representation and get results. Just kind of pulling on that thread of sentiment analysis and customer use, another common tool that Salesforce is very, this is again a common use case of Salesforce. Customer comes in, creates a ticket, talks about, hey, this is the issue that I'm having with your product, and submits it. That in a lot of cases, goes into something like Salesforce. The customer service representative will pop into Salesforce, get a list of cases that they've been assigned to deal with, and they will reply to you and give you your free month of usage if that's what you want. But the point here is they don't have to do anything. Like, we're calculating a Modsy score automatically every single time they enter the case. And in fact, before they even get to the case, we're categorizing and triaging that particular case file to different customer service reps depending on, say, their seniority or their expertise. I'm going to say this person is extremely negative, extremely angry, and is about ready to leave because they have a highly technical question. We're going to pop that over to a senior manager, customer service rep. Whereas this, they just gave us some positive feedback. I appreciate how amazing your SDK was. Great. We'll pop that over to some young junior member of our customer support staff, and they can deal with it. This ultimately saves a ton of money, a ton of time, and a ton of frustration on behalf of the support reps. And again, it's all, these folks never actually see the AI running. They just see the results, and they just see the fact that their cases have been pushed into the appropriate buckets or pushed to the appropriate people to take care of. Very common use case. And again, for those interested in the behind the scenes, Salesforce is a huge, complex tool, but behind the scenes, we just use some JavaScript to add an extension to call our Modsy model, pull in a job, and pull in those results so that they can be represented as simple HTML within the Salesforce application. And then finally, last couple of minutes here, I figured I'd just do a fun one. Users everywhere love their smartphones, so why not just run it here? We're not going to have in fact, some of you who were in our hackathon probably saw this particular one, but we're not going to, a user in general is not going to want to be running Jupyter on their iPhone, is not going to have that ability to run a model or something. What they're going to want is have it embedded within either an application, or in this case, just a shortcut. Like, the user understands, hey, if I want to identify objects in this photo, identify a face in a photo, in this case, identify sentiment in a snippet of text. I'm not going to copy and paste this into some web page. People barely do that for Google Translate. What they want is an automatic way, an app running on their phone, just something where they can click and have a result in a matter of seconds. So hopefully that, here's the code behind that. It's all, Apple doesn't exactly give you an IDE, so it's all just kind of copy and paste, drop values and stuff. But the point is, once we obfuscate all the modeling, we're going to hide all this behind just a couple button clicks as well. So what is the point of all this? I think my point is just consider the analyst. They have a ton of barriers against adopting AI and ML, against adopting what we have spent hours, days, so much of our professional time and lives working on, and creating these technologies, that are very, very exciting for everyone and very, very useful, but we do have to get them into the hands of these end users. Training the models barely even half the battle. We have to make it usable with existing tools and usable by the intended audience. So I guess that's my point. Consider that. Consider the end users' tools and their tool chain. And for any examples, come check out our docs page. We have, a dozen integrations and more being added all the time, and everything from Java wrappers to Python to full-on applications are listed here. So feel free to come by and visit. And as we close out the talk, feel free to drop into General, where we're just going to have a little more Q&A, and I think that's it. Any questions, come over to General, and I'll answer them there.